Hello, it's Alex here, Victor Kilo 2 Papa Radio Charlie, PRC. I've put together another video here on the Clansman 320 Manpack radio. This particular set that I have here, it's a great set, but when I get on the air, I always seem to get complaints about the audio, either clipping, being rough, being non-linear. It's just not right. So I've worked my way through all the audio circuits on the early stages of the receiver. Haven't found anything wrong with it. Suspected possibly something wrong with the synthesizer or even the 1.75 IF oscillator, maybe. So I've put it aside for a little while. It's one of those sets that I've changed all the capacitors in the power supply and the 110 volt ones in the synthesizer. Doesn't seem to fix it. Anyway, I've been thinking about it for a while. And I got a message from a friend of mine in England, Ted, G0REM, who said to me he had a very similar problem on one of his sets. And he'd actually traced it down to being the lower sideband filter. And what he did, he actually sent me a great video describing the tests that he performed on his radio and how he'd come up with the conclusion that the particular filter was at fault and it was causing irregular transmission of the middle range frequencies of the audio. So what I'm going to do now is I'm going to have a look at the circuit and see exactly what he's done, and then we'll have a look at Ted's tests that he sent to me. Okay, before we look at the video that Ted sent me, let's have a look at what he's actually doing. So what he's doing here on the microphone input, he's injecting a sinusoidal audio signal into here, and that signal then is passing through all of the filters and up into, I'll pull that across a bit, up here into to board 6C, where it goes through the VOGAD and then the IF gate. Through the audio, then comes out of the IF gate, goes over here into 6D, and 6D is where the 1.75 megahertz carrier gets mixed. Okay, and then there's a little bit of clipping adjustments and whatnot happening here. Out comes the signal, the combined audio with the 1.75 carrier. Down here through the switching arrangement, and this is where you switch between your AM and CW and single sideband, and then depending on where the switch is selected, goes through these filters. So the filter that's in question is this one here. So he's actually injecting, as I said, back in the microphone and monitoring the output coming out of the filters here back on board 6. Okay, so that'll help us understand the traces that Ted's sending us. Very, very ingenious way of testing all of that circuitry, which I think is damn good. And it certainly highlights the problem here, because to get to here, he's tested along the way. So yeah, so he's been good to here and then bad to this side of the filter. So that's the explanation of Ted's test. So let's have a look at what Ted has actually sent me.
Hi there, Ted G0REM with a Pauly 320, and this is what I'm getting the output from the IF filter. I'm feeding the 2 kHz in on the microphone socket, so if I just go on full power now, 2 kHz, and the trace on the oscilloscope is what's coming out of the filter going into the second mixer after the PA. So there's about 30 watts coming out there, that nice big signal. So if we drop that down, so that's 2 kHz, so if I drop that down to, if I drop that down to 1.6 kHz, there we go, 1.6, still good, 1.5, you see the trace is reducing, still got good power out, 1.4, power dropping off a little bit, 1.3, still reasonable, 1.2, 1.1, power dropping off now. It's 20 watts. 1 kilohertz, 10 watts. Look, it's 10 watts. So if we go, oops, if we go 900 hertz, there we go. Look, it's got about 5 watts there. Hertz, even less, 4 watts, 700 hertz, going up to 10, 600 hertz, nearly up to 20 again. Look, you see the trace is increasing now. Look, 25 watts, 400 hertz, almost back up to 30 watts now, 300 hertz, trace dropping off now, and there it drops off quite considerably. Look, that's going off the bottom of the filter now. 100 hertz, yeah, nothing. So there's definitely a big dip around about 800 hertz. That's 800 hertz. Look, 4 watts. So we're going to change the filter and see what we get. Let's take G0 REM with part 2 of the crystal filter problem. And I think we sorted it, replaced it for a second hand from our friends to Steve Slack. And if we test it again now, starting at 1.9, there you go, look, 30 watts. Come down, 1.8, 1.7, 1.6, 1.5, and the scope trace is fairly even. 1.4, 1.3, 1.2. 1.1, 1, go down to 900, 900, 800, dropped off a little bit, 700, 600, 500, 400, dropping off rapidly now, 300. So if we go back up to 800, that's pretty good. Well, let's put it this way, it's a lot better than it was. There we go. So the problem was the 1.75 meg LSB filter. I suspect this is a multi-stage filter, and perhaps one of the stages has actually failed, maybe a capacitor or something like that, I don't know, or maybe the crystal's gone duff and it's kind of like left a hole in the response of the filter, which is causing the power to fluctuate, especially when you're on speech frequencies. So there we go, it's fixed.
Okay, let's have a look at Ted's findings. Looking at the sort of readings that he got across the frequency range for the filter, he's seeing a deficiency between about 1.3 kilohertz coming down to about 700 hertz going down, and then it goes up again to the end of the filter. So looking at possibly what an ideal filter would look like, that's the sort of trace you would probably expect. Haven't really looked at it yet, but probably expect. And this is the deficient filter. So the audio frequencies in that range are not being amplified. So yeah, a bit of a deficiency at the receiving end when it comes to that range of audio. So no wonder audio's sounding crook, and possibly yeah, signal strength is suffering as well.
Hi Alex, Ted G0 REM here. Right, got the filter on the Nano VNA and producing a frequency that's starting at 1.745 and extended to 1.755. So what's that? That's 1 meg, isn't it? 1 meg span, I think. And oh, can't get to the knob now. Right, so if you actually see where the pointer is at the moment, get up there, it's right down there. It's actually at, that's actually what, 1.75. So that's the centre frequency of the filter. You see it's right down at the bottom there. There's our signal going in, and this, the blue trace, is the response coming out of the filter, which is this one here. So that's the output. Signal going in there. Let's move that around. Signal going in there. Signal coming out. So that's channel 0 on the VNA. This is channel 1 on the VNA. Filter in the middle. And you'll see from that. So 1.75 big deep null, and it goes up. What have we got there? So it kind of tops out there. 1.7496. That's 400 hertz. So there you go. That's where the. So that's the from bottom. So this is LSB. So this is the fundamental. This is the lower sideband. So there it goes up 400 hertz. It's really high, steep climb there. And then we go see it takes a dive, and that's 1.749 100. So what's that? That's 900 hertz then, isn't it? So yeah, it's about kilohertz, isn't it? 900 hertz, takes a big dive. There's 1 kilohertz, look. And then it's climbing back up here, look. And it peaks up there, 1.747 900. So what's that? That's 2.1 kilohertz, and it drops down a bit there, look, and then it goes up. What's that? 1.747 300. So what's that? That's 2.7, and that is the response. That's the top end response of the filter as per the spec. 2.7 kilohertz, and then a steep drop off, look, down to there. What's that? 1.7469, and I think 1.746. 400. So what's that bit there? That is 746 900. So that's like 747. So that's 3.1 kilohertz. So that's a big drop there, look. But that's good, look, too. That's 2.7. That's 2.7 kilohertz below 1.75. But that's that big dive, look there. So
okay, on with my radio. Okay, so after watching Ted's video and seeing a similarity to the problems that I had on my radio, I decided to set up a test very similar to Ted's test, but instead of injecting an audio sine wave into the microphone socket, I decided that I would use a audio tone generator. Now, I managed to install an app on my mobile phone, a free app. It's just called Tone Generator, and you can generate tone signals from 1 hertz up to goodness knows how many above the human ear. And it's pretty loud, and it's a scale that you can adjust. So what a great little tool to inject an audio tone into the microphone of the set. And then in order to monitor the output, I haven't monitored the output of the filter, but I've actually monitored the output of the set with a dummy load. So depending on the frequency of the audio that I'm putting into the set, I'm going to monitor the output coming out of the set rather than the filter. Okay, so which will give me a sort of an indication of how that audio is traveling through that lower sideband filter. Okay, so just to give you an indication of what I'm doing here, I've got the radio set on CW just to show you that I've got and this meter indicates the power coming out of the radio. Okay, so that's full power on CW. So what I did, I turned the selector to single sideband, and if I whistle into here, we'll get a similar result. Okay, so yeah, so it's dependent on the tone going in. Now pretend that this box here is my mobile phone, and what I've done, I've turned on my tone generator, and I've selected different frequencies of tone, ranging from, you know, way down about 100 hertz up to 3 kilohertz, and in steps I've turned it on, and I've hit the transmit button on the thing here, and I've taken a reading from the output of the radio. Okay, so I've sort of built myself some results across the lower sideband filter response. Okay, now this is easy. I mean, anybody can do this. All you need to do is have a dummy load, and you can just use a power meter. I mean, this particular meter of mine's a bit homemade, that's how I do it. But yeah, if you've got a simple power meter, yeah, just by injecting the tone in and reading the output on the power meter, you can get similar results. So let's have a look at the sort of results that I've got on my test. Okay, so I'm started down around, you know, pretty low frequencies, about 160. I had nothing coming out of the radio at 160, and then I got up to 200 hertz, and it started to tweak a little bit. The filter started to turn on, so I got 10 on my scale, and then up to 270, it jumped up to full power, 15. So as I'm increasing the frequency on my tone generator, so you can see the output's wobbling around, you know, pretty high. It's doing okay along the top of the filter there, of the curve. The problem gets around about 900 hertz. My filter started to exhibit problems. The output of the radio dropped down from 15 units down to 4 at 1000 hertz, and 1100 hertz it was 5, and you know, it took right up to about the 1200 hertz before it started to build up again, and then it stayed high all the way up to just under 3000 hertz. Okay, so my filter, my lower sideband filter, was exhibiting a very, very similar problem to Ted's filter, but Ted used a little bit more of an elaborate test. I used this simple audio tone generator and monitoring the output of the radio. Now, anybody out there could do this easily. It takes like 10 minutes, and you can diagnose whether your set has deficiencies in the lower sideband filter. Okay, very good. So what I've now established that the filter's crook. I'm going to grab myself another filter. I happen to have a spare here somewhere, and I'm going to do a test on that filter and have a look at the response that I get on that test. G'day Ted, how you doing, mate? Very impressed, mate, with the videos that you made. Yeah, so what I've done this morning, I've tried to replicate, mate. Yeah, this is the spare one that I've got here, mate. So I've virtually set up my nano with these parameters, right? So yeah, 1.746 to 1.751, and I've sort of replicated what you've got there. So yeah, that's the curve, the blue curve that I'm getting through the filter, mate. So yeah, it's there it is. Okay, I've just pulled the setup apart and yeah, stripped it down. Took the board off underneath. There's some screws involved there from the board underneath, and a lot of those screws there with the green circles around them all around the place, and that board swings out, enables access to the bottom of the filter. And yeah, remove the old filter, 2 solder connections, a couple of nuts there that you need to get a nut runner on, and you definitely need a nut runner. There's no way in the world you'll get that front one off without a nut runner. Yeah, so yeah, just a simple change, and there's the replacement there. So we'll put it back together now and see how she goes. Okay, this is the filter that I've removed from the radio. This was the one that was giving me trouble. So we had a look at the replacement that I was putting in and how the curve was on that. Let's have a look at the one that I've taken out. My goodness gracious me, look at that. Ah, well, there's the dip around about the 900 to 1200 hertz range. Yeah, wobbling along the top, and wow, what a difference. Yeah, my goodness, it's plain to see that this particular filter was causing me the problems, and it was very deficient. Okay, we're back again. I've just reinstalled the new filter in the radio, and I've carried out the audio test that I did before, the same audio test. And look, I can't show you that test being conducted because the phone that I'm recording on is the same one that's got the audio tone generator on it, but no mysteries there. Okay, so I've set it up exactly the same. I've gone through the same frequency range that I had before. I haven't written the results down, but I'll tell you what they are. From the bottom frequency down here, in fact, the new filter went slightly lower, and it jumped straight up to the full 15 of the full power, and a 14-15 readings through the whole frequency range, right up to just under 3,000 hertz. So this particular filter that I installed, very flat top results, very good, and that's pleasing. Looking at the profile of the filter before I put it in. So I would say that we've cured this particular problem, and it's all thanks to Ted over there in the UK. Yeah, Ted G0REM. He was the bloke that discovered this problem, and I've just followed Ted's lead, and I've been able to repair my radio. And I'm sure that when I go up the park next time and get on the air, I'm going to get those good audio reports that I expect. And by the way, all this was achieved through our WhatsApp Clansman 320 group that I run. Without having that group and sharing information like this, it wouldn't have been possible. So thank you again, Ted, and to the guys in the group as well. Signing off, 73.